Welcome back to Summarize Science, where we dive into the latest breakthroughs in technology. Today, we are looking at a fascinating new paper that shows how language models can actually improve themselves. Currently, most AI models generate answers by predicting the next word, but this can lead to mistakes on really hard problems. The researchers noticed that common ways to find better answers, like searching through many possibilities, have two major flaws. First, they often get stuck in a narrow range of thinking, and second, they do not get enough feedback until the very end. To fix this, a new framework called Bidirectional Evolutionary Search, or BS, was introduced. Think of it like giving AI a bit of biological inspiration to help it solve puzzles it could not handle before. BS works by using forward evolution and backward decomposition at the same time. In the forward part, the system does not just try to guess the next step, it actually combines and edits different ideas. They use techniques inspired by nature, like crossover, where parts of two different promising answers are spliced together. There is also combination, which merges the best bits of two paths, and deletion, which removes parts that are not working. This allows the AI to escape its usual patterns and find creative solutions that it would not normally think of. While this is happening, the backward search is breaking down the main problem into tiny, checkable subgoals. Instead of just waiting for a final right or wrong at the end, the model gets constant feedback on whether it is meeting these small goals. This is like a teacher giving a student hints for every step of a long math problem rather than just grading the final result. Theoretically, the researchers proved that these evolutionary operators allow the AI to reach regions of logic it usually misses. They also showed that breaking goals into pieces can exponentially speed up how fast the AI finds the right answer. In tests, this method was applied to tricky logic puzzles called knights and knaves, where you have to deduce who is lying. While standard AI models struggled and even got worse with training, BS showed consistent and significant improvements. It was also tested on complex multi-hop reasoning, where an AI has to search through multiple documents to find a single answer. The results were impressive, with the BS-trained agents becoming much better at searching and finding correct information. Even on open-ended problem-solving benchmarks like circle packing, BS outperformed existing open-source frameworks. What is even more surprising is that this extra brainpower does not necessarily mean a massive increase in cost. In fact, it is often more efficient than trying to force a basic model to guess the right answer millions of times. So, to recap, BS is a two-way street that lets AI evolve its answers while getting constant feedback from subgoals. It combines different reasoning paths like DNA, allowing the model to reach breakthrough solutions. This means we might see much smarter AI in the future that does not just rely on having more data, but on thinking more clearly. Instead of just making models bigger and more expensive, we can make them better at self-improvement. This research opens the door for AI that can solve scientific and mathematical problems that are currently out of reach. It is a huge step toward more reliable and creative artificial intelligence. Thanks for watching Summarize Science, and stay curious about where this technology will take us next.